Okay, in section 3.1, we're going to start talking about the inverse sine and cosine functions, and indeed all the inverse trig functions. But before we get started on that in earnest, let's remind ourselves a little bit about inverse functions. Now, in the Detroit area, there's kind of a cool relationship between the mile roads and the street addresses. So, on your major north-south roads like Telegraph, Mound, DeQuinder, Woodward, if you take 2,000 times the mile road and then add 5,000, that'll give you the street address. So for instance, Lincoln is 10.5 mile road. Okay, 10.5 times 2,000, 21,000, plus 5,000 is 26,000. So the BP gas station on the corner of Lincoln and Woodward has an address right around 26,000. So, I mean, that's kind of a cool relationship if maybe you're the postman. It doesn't help us out too much otherwise. But what is a cool relationship is something that goes the other way. The inverse function. A few years ago, I had a student invite me out to his family's cycle shop, Hellybuck Cyclery. I had no idea where that was. He goes, oh, it's on the 61,000 block of Mound. I looked at him, I'm like, there's no way I'm going out to 28 Mound. I live in Royal Oak. He was surprised. Well, how did you figure that out? It's because I applied an inverse function. Well, I didn't tell him that, but that's what I did. But really what an inverse function does is the opposite of what the function does. So the function takes 11 mile road and turns it into an address. The inverse function does the opposite. It undoes what the function does. So one goes one way, one goes the other way. One goes from the domain to the range, your x to the y. The other one goes from the y to the x. Now to study this and understand the important properties, let's run through this a little bit quicker than I might usually. And we're going to trim down our function. Instead of using 2,000x plus 5,000, let's use 2x plus 5. And just understand the thousands part. Suppose you're at 1 mile road. All right, that means that you'd be at the 7,000 block. Now, I'm not sure that this goes all the way that far south. 1 mile road, I think, would be Warren Road if it went all that way far south. 3 mile road would then be, 11? And 5 mile road would be 15. So it'd be in the 15,000 block at 5 mile road and, say, Telegraph. Now let's plot these points. And you're going to kind of have to estimate them a little bit. So we've got 1 and 7. It's about here. And then 3 and 11, someplace up here. And finally 5 and 15, that last point up here. And let's play connect the dots now. Now I don't envision anything going below 0 mile road, so don't go past the y-axis. But there you go. There's your inverse, or there's your function, y equals f of x. But how about the inverse function? The inverse function is going to do the opposite. In the case of this example, if I was at the 7,000 block, then I'd want the inverse function to tell me what mile road I would be at. So if I put in a 7 into this inverse function, what should I get out? A 1. If I put in an 11, 3, and then last but not least, 15 and 5. So let's plot these. 7 and 1, 11 and 3, and then 15 and 5. And there's a lot of things that I want us to get out of this graph. Let's start by playing connect the dots. Now the notation here, the correct notation is f negative 1 of x. And that's the inverse function. Let me be very clear about something. It is not the reciprocal. Now I use this handout for my intro algebra class or my intermediate algebra class, so I use a very user-friendly g of x. But it's really f negative 1. It's the inverse function. That's what we're going to find here. Now there's a couple things to notice about our function. First of all, let's remind ourselves a little bit about the domain and range. The domain is the x values that you can put into your function. So the domain of this function, let's see, where do I want to write this? Let's see. The domain of f, well, it could be 0 up to infinity. So let's go 0 to infinity. The range of f will be the y values. So if I put in x equals 0, what y value should I have here, even though it doesn't look like it's plotted very well? Well, let's find it from here. 5. If you put in a 0 for x, you're going to get a 5 for y. So 5 to infinity. So that's the domain and range of our function. Let's look at the domain and range of the inverse. So the domain of f inverse, well, it doesn't start at 0, does it? Remember, we're dealing with the x values. Where would you guess this starts? Well, it has to be a little bit to the left of... Yeah, it starts at 5 to infinity. How about the range? Good. 0 to infinity. Now, do you see anything that's kind of noteworthy in looking at the domain and range between f and f inverse? They switch, right? That's exactly the conclusion that I wanted here. And that's actually already written for you on your handout here. Domain and range between the function and the inverse. And keep in mind here, g represents the inverse. They switch. So if you have one, then you can get the other. What else? We need to know how to calculate. Well, let's see. It's not. Here's the steps in calculating the inverse. One thing about the function that and its inverse that is kind of helpful is this understanding. If I did the function of 11-mile road, I'm going to get here. What if I then apply the inverse function? Where am I going to go back to? 11-mile road. One does something, the other one undoes it. So when you apply a function, then its inverse, you get back to where you started from. And that's what this is saying. The function of the inverse gets you back to where you started from. There's one last conclusion about this that I want us to look at. This line here, the line y equals x, is kind of important to this graph. Is there anything noteworthy about these two functions relative to this line y equals x? Okay. All right. Somebody said they're mirror images of each other. So the graph of f of x and f inverse of x are mirror images around the line y equals x. So those two graphs are mirror images of each other, here and here. And that's a nice, important thing to know relative to the graphs of your function and its inverse. Let's see if we can apply that now to some sine and cosine graphs. On the flip side of your handout, I've got two graphs. First thing I want you to do is figure out which one's which. Which one's a sine, which one's a cosine. Just write it down. Give your fellow students a chance to figure it out if they're not quite as fast as you. But label these. Which one's sine, which one's cosine? Yellow. Yeah. All right. All right. So what graph am I looking at here? Which one's this in unison? Sine. Yoo-hoo! Good job. You made me look good. All right. Thank you. Y equals sine of x, because it starts at 0. Cosine of x is going to start at 1. So y equals cosine of x. Now, what we have to envision is reflecting this graph around the line y equals x. So basically, here's your line y equals x. You're going to pick this up and flip it like that. What's your graph going to look like when you flip it like that? Which one of these is going to be the graph of the inverse sine? The first one or the second one? First one, right? Because it goes through 0, 0. So does this one. All right, so the first one is the graph of the inverse sine. Wow. I wouldn't exactly be right if I called this a crazy looking function, because it's not a function. Why is it not a function? Perfect. It fails the vertical line test, right? So here's what we're going to do. We're going to kind of cheat a little bit. We're going to make a little restriction. We're going to say, you know what? We're going to throw out part of this graph. I'm going to keep just this little piece.
The inverse that doesn't pass the vertical line test, therefore it's not a function.
The inverse is, as it is here, is not a function. But if you make a little restriction, and this is kind of like an inset here, right? I'm zooming into this. Here's our restricted function. Does this pass the vertical line test? Yeah, that is a function. So let's understand some things about the inverse sine, because that's what this is y equals the inverse sine of x. Now, one thing that you need to be clear on. This has nothing whatsoever to do with the cosecant. All right, you can't take the reciprocal of the sine and get, or the inverse sine has nothing to do with the cosecant. Period. End of story. Can anyone tell me what these endpoints are? Wasn't thinking asymptotes. I was just thinking of coordinates. All right, so -1, negative pi over 2, and 1 pi over 2. So with those, let's see if we can't fill in the domain and the range. The domain, remember, was your x coordinates, right? So what are the x coordinates that you associate with our inverse sine function? Good. 1 to -1. So in doing this from lowest to largest, left to right, -1 to 1. How about the range? Good. Negative pi over 2 to pi over 2. So there's your domain, and there's your range of the inverse sine function. Now I'll show you a way to try and get that for yourself on your calculator, because what's going to happen is on the exam, sometimes you're going to go, oh, what's the domain of the inverse sine? You're going to be stuck, and you're going to be drawing a blank, you'll be panicking, but I'll show you a nice easy way to get that. What I want you to do is kind of do the same thing here for the inverse cosine. So here's your graph of the inverse cosine, but here we've restricted a little bit. And we played the same game here that we did with the inverse sine. And that is, we said, all right, you know what, let's just kind of throw out a little piece and just focus in on something that's a function. So we truncated a little bit. I think we took out this little piece right here. So see if you can't come up with the domain and range of the inverse cosine. It's a good question. We do it out of convenience. We keep the angles close to 0 and close to the origin. You could define this in other ways to pick out different parts of this, but our choice here is mostly out of convenience. Okay, but like I said, I will come up with I will show you a way that you can get the range here, so that when you're stuck and you're like, oh, where does it go, that you can figure it out. Okay. Let's look at the domain here. What's the domain of the inverse cosine? -1 to 1. How about the range of the inverse cosine? 0 to pi. So the domain is the same, but the range is different from sine inverse to cosine inverse. They are different functions. All right. Let's understand a little bit more about what these functions tell us. Let's start out with a friendly example. Sine inverse of 1/2. What this represents is the angle whose sine is 1/2. That's what the inverse is representing. So you're kind of going the opposite. Instead of saying, okay, I want the y-coordinate of a point associated with an angle on the unit circle, now you're going the opposite way, saying, okay, I've got the y-coordinate, what's the angle? Let's do this on our calculators, and let's make it a little bit easier on ourselves. Most of us, myself included, don't really recognize a lot of these angles like pi over 6 and 2 pi over 3 or 4 pi over 3 in radian degrees. So temporarily, let's switch our mode back to degrees. And then we'll convert as necessary. So put your mode in degree mode, then quit. Now hit the second key and then the sine key. Notice you get a different notation here on your calculator. You've got the sine inverse. Sine inverse of 0.5. This should be the angle whose sine is 1/2. 30. How could you check it? How about if we take the sine of 30? Get back to where you started from, right? You do the function, then the inverse, gets you back to where you started from. So when you're taking the inverse sine or inverse cosine, you're getting an angle with certain properties. And that's what the inverse is representing here. So let's do a couple more examples with the inverse. For example, let's stick with the inverse sine of square root of 3 over 2. This is going to be an angle whose sine is square root of 3 over 2. And then we can also do problem number 22, sine inverse of negative root 3 over 2. And that's going to be an angle whose sine is negative root 3 over 2. But let's try these one at a time. I'm still in degree mode because chances are I'm not going to recognize these angles in radian mode. So second sine second square root of 3. The one thing you have to be careful of in this one is to exit the square root. I need to hit the right arrow and get out of the square root and then divide by 2. Oh, 60 degrees. Yeah, that makes sense.
Points taken off if we don't put the little degree thing.
You know, as long as it's obvious, I'm not really going to worry about it. No, I'm not going to bust you on that one. Again, you can check it by doing the sine of 60. Now that may not look familiar, but if you compare that to square root of 3 divided by 2, okay, it looks familiar.
Is there a negative in front of it?
Come on, can you help out? Why don't you try this one? Try this one, see what you get.
So all of these are going to be in degrees.
Yeah, they're all in degrees. Now, there's a good reason for that, though. And that is, if I put my calculator in radian modes, I wouldn't recognize these things. So second sine inverse of negative square root of 3 divided by 2 should give me negative 60 degrees. What if I ask for an answer between 0 and 2 pi? Do you think negative 60 is acceptable? No. Let's figure out what we would have to do here. Because a lot of times, you know, this is what you would do, this is what I would probably do. So we get negative 60 degrees. Well, the first thing I'm going to do is I want to turn that into a positive angle. So instead of negative 60 degrees, what's the positive angle? In degrees. Let's start in degrees. 300, right? Because the whole circle is 360 minus 60 is 300 degrees. And last but not least, let's convert 300 degrees to radians. So 300. What do I have to multiply by to convert to radians? What's that? Good. Pi over 180. And let's see, 60 is going to go in here 3 times and here 5 times, so I'm going to get 5 pi over 3. Quite often for problems like this, you're going to be asked for an answer between 0 and 2 pi. So giving me an answer of negative 60 doesn't fit that. So we had to do 2 things. We converted it to a positive angle instead of the negative angle, and then we converted that angle to radians. Okay.
That'll always be true. So if it was like negative 45 degrees, you would just subtract negative 45 from 360?
Yeah, so you'd have 315, and then convert that to 7 pi over 4. Yes, sir?
Sorry, how do you get 5 pi over 3?
Oh, you just reduced it, right? 60 goes into 80, 180, 3 times. 60 goes in here 5 times. So if you're not really comfortable with that, if you're like, oh, you know, I just really struggle with that, take 300 divided by 180, and then hit the math key to convert your answers to fractions. Hit the math key and press enter twice, and there's my 5/3.
That was being a goof.
That's all right.
In my mind, I thought it was 360.
All right.
That way you always just add a pi.
Yeah, and so this way, yeah, you have to add the pi when you're all done. You don't want to do it ahead of time. Speaking of the pi, let me go back and show you why I'm not doing this in radian mode. So if I put my mode in radian, okay, yeah, all right, I can do that. So I want the inverse sine of the square root of 3, or actually it was negative, square root of 3 divided by 2, and I get that ugly thing. I mean, most people aren't going to look at that and go, gee, I know what that is. That's minus pi over 3, which I'll convert to 5 pi over 3 to get a positive angle. You know, if you can do that, great. Don't let me stop you. Is there a question back here? Don't put the pi in there. Just do it without pi. And then add the pi when you're all done with the calculation. Because the pi is going to make it an irrational number. And your calculator won't understand it at that point. Is there another question? There's a hand up. Yes.
Like the very last part that you wrote, the 0 is less than or equal to 0, and less than,
That's a typical restriction on answers. Is you want answers between 0 and 2 pi. So that's typically where we're going to try and find our answers. Is somewhere. Yeah, that'll be given in the question. It's generally what's going to be understood. Yeah, if it's 2 pi, then might as well just write 0, right? Because they'll be the same angle.
that is a 0 in the middle of those two.
That's a theta.
Theta, okay. I was like, that's why I was confused.
Oh, okay. Yeah, that's a theta. It's not going to work out that you're going to end up with an angle of 2 pi. So if I put less than or equal to 2 pi, it really wouldn't matter. We're not going to end up right at 2 pi. That'll just rarely happen. So, but traditionally, this is the range of angles that'll be given. Okay, good questions. Let's try some more here. Now they're not all going to work out nice and even. So let's take a look at an angle or a problem like number 30. This is page 192. Sine inverse of 1/8. Good question. No, this one's not pi over 8. It's just 1 over 8. Well, what you're going to get, and this is not a bad idea to keep in mind, when you do the inverse sine or inverse cosine of these functions, what you're going to get is an angle. Theta is the angle whose sine is 1/8. So equivalently, let me zoom out a little bit. Sine of theta equals 1/8. These are saying the same thing. So your job is to find the angle whose sine is 1/8. And that'd be different than pi over 8. Let's keep it in degrees. So, I don't think I'll recognize this in terms of radians. So back in degrees. And this one's probably not going to work out, like I said, to be something nice and even. That's okay. Sine inverse of 1 divided by 8. A little bit more than 7 degrees. Okay. So let's see. Approximately 7.18075, etc. Typically speaking, I will tell you how many digits I want this rounded to, and more often than not, it's going to be to the 10,000th place. That would be right here, the 4th digit. If I round this to the nearest 10,000th place, what's that going to be? 1808. And we'll put degrees here just to be safe.
Okay, so since this one does not have any restrictions, we don't have to use it in radians. Because the one above it
Yeah,
is negative.
I'll be clear about where I want this in degrees or radians. But yeah.
So that would just be my answer.
Yeah, that's it. So
Which one again?
that's it. That's in radians. That's in degrees. That's in degrees.
I think the only time it's in radians is
If they tell you some that it has to be between 0 and 2 pi, then implicitly they're telling you your angle has to be in radians.
okay.
Yeah.
So that means that we're going to have to convert normally.
Yeah, you have to do something one way or another. Let's try some other another trig function. So for instance, problem number 26. Cosine inverse of 0.6. So you're looking for the angle whose cosine is 0.6. So call that theta. Equivalently, cosine of theta is 0.6. Let's keep it in degrees. Let's keep it in degrees. What are you getting? 53.1301 degrees. Good. How could you check it? If you're looking at that going, yeah, I just don't know. How could you check it? Yeah. In fact, here's an easy way to check it. Hit the cosine button. Now hit the second button and then the enter key. Whoops. No, not the second button. No, let's see. Sorry. Second answer. So cosine, second, and then the answer key, which is right here. That's going to take the cosine of your previous answer. That should give me exactly 0.6. Nice. Overall, what's that saying? It's saying the cosine inverse of the cosine of 53.1301. No, I guess I wrote that backwards. It'll still work. It's 0.6. These two functions, no, that's not right. That'd be 53.1301. These two functions are going to cancel each other out. What one does, the other one undoes. I should have written this in the other direction. Let's try one with the inverse tangent function. You know what? I promised you something that I haven't delivered on yet. I'll take care of that too. The $1 million, I don't think, we rewind the tape a little bit, I don't think I made that promise today. Now one thing it's hard to keep track of is the range for your sine inverse and cosine inverse. They're different. The range for the sine is negative pi over 2 to pi over 2. The range for the inverse cosine is 0 to pi. But if you're stuck on a test and you're like, oh, God, I just don't remember which one's which, here's what you can do. The extremes of the domain are negative 1 to 1 for both the sine and cosine inverse functions. Let's take the inverse sine of negative 1. What do I get? Negative 90. All right, that makes sense. What angle has a sine of negative 1? Okay, that's at negative 90 or 270. What if I did the same thing for the inverse sine of 1? Then I get the other extreme. Now this is in degrees, but it's still telling you the same information, right? Negative pi over 2 to pi over 2. How about for the cosine, the inverse cosine? Inverse cosine of negative 1. 180. What about the inverse cosine of positive 1? 0. So there you go. You know, the degree version of 0 to pi is exactly what this is. So if you're stuck, you can kind of reproduce these things for yourself. It's a little way to use the technology you have right here to help you out. Let's see. The domain, the range for the inverse tangent is going to be the same as that for, or mostly the same as that for the inverse sine. The only difference is that you're not going to include the endpoints. It's going to be negative pi over 2 to pi over 2. let's play around with an inverse tangent problem.
So the range for the tangent is what?
So the domain, let's see, the range for the tangent inverse is negative pi over 2 to pi over 2. I don't think that trick that I just showed you is going to work for the inverse tangent.
No.
Yeah, it's not going to work so nice. Let's try number 32. Tangent inverse of negative 3. You could, yeah, you could be asked to put that in radians. So there's the inverse tangent. That's in degrees. If you're asked to come up with an angle between 0 and 2 pi, there's probably a couple steps that I would do. First of all, let's convert this to a positive angle.
278.4.
The easy way to do that is just to add 360 degrees here. So hit the plus key, plus 360. There's your positive angle. Now you need to convert that to radians. So I've got 288.43 stuff. I don't want to convert that to radians. What do I do to convert this to radians? What do I multiply by? Yeah. Pi over 180. This is not going to work out to be a nice number. So it's up to you. You can divide by 180. I get 1.602. Have I used the pi yet? No. So it'd be appropriate to put pi here. Or you don't have to keep the pi out here. You could just times by pi, and finish it all off. It'd be 5.034. So either one is fine. If you don't want to multiply by pi, just leave it out, or multiply by pi. Either one works. Good? Okay. Let's take a break here, and we'll come back in a few minutes and keep working on this.